What's going on? Hello and welcome to MEL Science. A delight and a pleasure to have you all. This is a live show. So I should just switch my gallery to this so I can see who's in. So it is live, so you can switch your cameras on. It makes it a little bit more personal if you would like. And if you would like me to sort of see things that you're doing, and I can maybe correct some of the signs if it's all. But who we got? If I just quickly scan and see, we've got Ralu Kurdobo or something like that. I'm so sorry about it if that's not your name. Ralu, her name has changed. So Chantal, hello Chantal. And we have Ram, hello Ram. We have Adrian. We have Philippe, hello and welcome. Lovely to have you on board. And thank you very much for subscribing to MEL. We are going to charge through the wacky world of chemistry and electricity. Okay. If you don't want to put your webcams on, there is the chat, and you can communicate with me in chat. So you can write little messages and stuff like that, and I will answer those, hopefully. Hello, Philippe. Hello, Philippe, in chat. Lovely, got you there. That's wonderful. Okay, cool. So, without much further ado, might even throw in a few jokes for you. Let's scan through to I'm going to change my position so you can see the desktop. So we've got the kit. I've just changed that for a second. Okay, if already can see, we're going to do this one today, which is the chemistry and electricity kit. So what do we need for that? You do need a lemon, please. Don't cut the lemon just yet, but you need a whole lemon before we begin. Hello, we're Kiana and Lucas. Hi, Kiana and Lucas. Hello. Guess good, lovely, spot on there. Lemon. Philippe has got the lemon. Don't cut it yet. Do not cut your lemon yet. We need to do something careful with it. So what do we need from the kit? We need 2 sets of wires. So you need 2 sets of your wires. The chemicals that we need are the zinc sulfate. So you need the zinc sulfate. We need the sodium hydrogen sulfate. So sodium hydrogen sulfate. And we're going to need 2 bottles of the copper sulfate. So 2 bottles of copper sulfate. And then you've got 4 of these little lidded sample tubes. So 4 of the little, and a little stand for them. In your kit, you will see also 2 LEDs. So these are little light emitting diodes. So 2 little LEDs. One is green and one is red. As per normal, as you've got your chemistry kit, so you've had these kits before, so you know what this is. Little paper clip for pucking out the... Can you record? It's being recorded, Kyan and Lucas, it's being recorded. So this will be available live tomorrow at some point, okay? So, or later on, so don't panic, don't panic. You need your tray. You also need your little salt bridges. So these are little tiny felt strips, little absorbent felt strips, and we're going to turn those into a salt bridge. Then from your kit, you need the magnesium ribbon. So magnesium, you're very welcome. You need the copper, elemental copper. So these are really interesting because let alone these are elements, pure elements. So it's elemental magnesium, copper, and then finally we have zinc. Okay, so we've got a bit of zinc. Okay, so I'm going to move this stuff out aside. And of course, your 2 little experiment cards are the lemon battery and the Danielle cell. So we're going to start with the lemon battery, and then we're going to go into the Danielle cell. Okay. So namesake like mine. Okay, no problem at all. And we've got another AC. AC, hello AC. Love to have you on. It is live. If you want to sort of pop up your your viewing screen, that's perfectly fine. If you just want to communicate and chat, that's great. Okay, so without much further ado, I'm going to move some of this equipment aside, and we're going to start with the lemon battery. Now, I've got some slideshows, and I will explain the science for you. So first of all, we need the magnesium, and you need the copper. So we don't need the zinc for this one. Okay, we need magnesium and copper, and we don't need those reagent bottles for this part of the practical. So just move those to one side. You also want the red, and we don't need the green LED, we need the red LED. So if you pop the red LED there, okay. Now the lemon, as I said to you, now very important, if you want to have an electrolyte, which of course is a conductive liquid, if you want to have an electrolyte in the lemon, you actually have to free up some of the lemon juice inside the lemon. And of course, all that's locked up in little lemon cells and then the tissue of a lemon. So we need to give that a little roll with a bit of pressure to burst some of the cells to make sure that all the lemon juice is flowing freely inside it. So give that a nice little roll until it's nice and squishy. Okay, so don't burst the lemon. Obviously, just keep it rolling until you can feel it going nice and squishy first. Okay, so near enough, no one's got their cameras on, so I can't really see what's happening. But if I'm going to ask little questions, if you could give us a little thumbs up to say you're okay or something, that would be great. Okay, you don't have to put your cameras on. It's always nice to see you. But if you put a little thumbs up, so I know that everything's okay, that's great. Okay, cool. And of course, you can put your thumbs up on I think there's a little tiny button on the side that says you can put your thumbs up. So give that a nice little roll. Nice little roll. Oh, I've got somebody else who's joined us. Caroline. Hello, Caroline. Love to have you on board. Cool. I've got some thumbs up. Kina's given us a thumbs up. AZ's given a thumbs up. Lovely. Cool. Right. Now, my lemon has got pretty squishy. And Ram said thumbs up. Cool. It's got pretty squishy. So now what you want to do is cut carefully your lemon in half. So cut your lemon in half. So it's nice and squishy lemon, like so. Whoops. Okay, so pop your lemon like that. Now you might, if you've got it handy, a little bit of tissue paper. So I've just got a little bit of tissue paper to give your hands a little wipe and then dab up any excess lemon juice or something of that nature. Okay. Right. So next, what we're going to do, this lemon, and I'm going to explain the science in a second. I've got a little slideshow to explain this, okay? So this lemon's full of acids, lots of different acids. You've got citric acid in there, you've got ascorbic acid, and you've got a range of different acids in there, okay? And those are liquids that can conduct electricity, okay? And also react with things. So if you open up your packs, your metal packs, and what you need to do is take out 2 magnesium strips. So I'm just going to take out 2 of these magnesium strips. Well, I'm going to try to. I'm going to just cut that open, to be honest. So my little one's jammed a bit, so I'm just going to cut that open. Okay, so if we take out 2 of these little magnesium strips. There we go. 1, 2. Make sure the others slide back. And then you want 2 of the copper strips. Okay, so 2 of the copper strips. And my one's proving a little bit tricky to open for some reason. So I've just cut the top off of these ones just for the time being, okay? So 2. Now you'll notice the copper is in little rods. Magnesium is not a particularly ductile metal. It's not as ductile as, for example, copper. One of the reasons that copper is beautifully ductile, it can be drawn into long wires and strips, okay? So I've got 2 rods of magnesium and 2 rods of copper. Right, so the next thing we need to do is get your red strip, and I'll just move this back, I think, so everybody can see what I'm doing. And it's great. So if you get your one of your red leads, okay, and one end of the red lead, put it to the magnesium. So make sure the little crocodile clip is nicely connected there. And then with the other end of the red lead, we're going to connect it to the copper. Okay, so make sure that's nicely, firmly gripped into the copper. Is that okay? The next thing you do is get the black lead, so one of the black leads, and put that into the magnesium. So the other little bit of free magnesium you've got. So right up the top, make sure that's firmly gripped. Okay, so firmly gripped. And then with the other red lead, you're going to grab the copper, like a strip of copper. Okay. Right, so you should have 1 red lead with copper, 1 black lead with magnesium, and then I'll move this back all the way back here so everybody can see that more clearly. 1 of the leads with magnesium and also copper. So I'll just stop there for a second. If everybody could give me a little thumbs up to say that you're all okay. If I get a couple of thumbs up, then I'll know more or less on Kate. I've got a thumbs up from Adrian. Yep, cool. Awesome. Right, brilliant. That's great. Thanks, guys and girls. Right, so first of all, let's get the magnesium and the copper strip together. So the red lead with the magnesium and copper strip together. And if you push deep into the lemon, the piece of magnesium on one side, and then the copper into the lemon on the other side, so the other bit of lemon. Now you'll see immediately there are some bubbles appearing on the magnesium. That's because the acid in the lemon is attacking the magnesium, okay? Right, the next thing we need to do is get the magnesium strip, So if you get the magnesium strip and stick that into the copper side, so get the magnesium strip on its own, so this one with the magnesium strip, and put that into the other side of the lemon, but on the copper side, like so. And again, you'll see that nice little reaction taking place. And then, that's just turned around for me, which I didn't want. And then with the copper wire, with the copper thing, you put that into the magnesium lemon and push that deep into the lemon itself. So what you should have, just have a little sense check of this. If you look at the bits of metal that are now stuck in the lemon, you should have magnesium, then copper, then magnesium, then copper. So look at that again, magnesium, copper, magnesium, copper. Cool. Now we have almost got a complete circuit here, but we haven't got one quite yet. So what we now need to do is see whether or not there's an actual electric circuit here. So with our little LED, you should see that the long leg is the positive leg, and the positive leg is the copper leg. Okay, so the long leg is the copper leg. Okay, so the long leg here is the copper leg, that's the positive one. So connect up your clip like that, and then the black end goes to the short leg here, this one that's bent, and then you just clip that open, and then hopefully, yay! Now it's very bright here in the studio, so I'm going to turn the lights down for you so you can actually see a little fast. Can you repeat from what's happening to them? Chantal, of course. I'll do that, just 3 seconds. I'm just going to turn these lights off so that you can see I'm not cheating, that I've actually got some light coming out of my LED. And hopefully you can see, look, I've got a little bit of light glowing out of my LED. So it's all working absolutely. And the light, you look down on the LED to see that. Okay, so I'll just switch those lights back on. So quickly pop those on. Okay, so just once again, so Chantal, I'm so sorry. And I've got two more. I've got Tanner and Chris. Hello, Tanner and Chris. Welcome. Thank you very much for joining us. So what we've got here, look, if you just think, if you wanted to do this a different way, you could just put the magnesium strip in this bit of the lemon. I'm going to disconnect this so that you can see maybe more clearly for those people who are joining a little bit later. Okay, just a little bit later. And just disconnect that one for a moment. So you could start this way. If you wanted, just by putting a bit of magnesium into the one side of the lemon, then the copper strip, then the magnesium strip, then the copper rod. Okay, and then if you get this one lead, Chantal, if that's okay, you just connect the copper to the magnesium, like so. Ta-da! And then the black lead goes to the magnesium on this side, and then the copper goes to the little red clip on this side, and our little LED comes on. I know you can't see that without me turning the lights off, but hopefully it's working for you. Is that okay? Has that worked for everybody? It's all gone quiet. There's a thumb up. Adrian, awesome. Thank you so much. Kiana, lovely. Ram says yes, cool. And Caroline says yes, lovely. Excellent, cool, fantastic. Right, well, I think we need to explain a little bit of this chemistry, I think. So what I'm going to do, if you don't mind, I'm just going to introduce a bit of the science, a bit of the chemistry, so hopefully it all kind of makes sense. And you can leave your little LED running there, no problem at all. So where are we? So chemistry, electricity, set. So it all starts, really quick whistle stop tour, all starts with the Greeks discovering that if they have a little bit of amber and they rub some amber, Luigi, indeed, it attracts things. So they call amber Electra. Now I'm going to skip through a couple of generations and stuff like that. There's lots of fantastic science. You can ask me loads of questions. But we get to a point where society is trying to think, or scientists are going, is there a connection between lightning and amber and all sorts of static electricity effects that they had been aware of? And they wondered whether or not life itself had something to do with lightning and all that kind of stuff. Now, Luigi Galvani and his wife, they were conducting experiments with sort of frogs, And they noticed one day that when they touched the frog's leg, it jumped. And they went, indeed, the whole of life is to do with electricity. Well, what this phenomena, they didn't call it electricity, this phenomena, okay? And he had a mate, Galvani, so he published this paper, and he went, I've discovered life is to do with electricity, effectively. But he had a mate called Alessandro Volta, who you may know, of course, with the name Volts, for good reason. And he came to Galvani's experiment, and he went, hey, Galvani, I don't think you're right. It has nothing to do with the fluid electricity of the frog. It is to do with the different metals that you use. Okay? Hey, I've been practicing all week. How you doing? And Galvani says, hey, no, Volta, I have the right idea. And Volta, oh, no. So Volta shoots off, and he builds the first pile, and this is his experiment. This is actually Volta's first pile. It's what's called the voltaic pile of copper and zinc and copper and zinc and copper and zinc in between little bits of sulfuric acid. And he then, using devices that he had at the time, not a voltmeter, because he hadn't been invented yet, of course, or a light bulb or an LED, but he realized that if you touched your tongue, for example, you got this shock. And he went, you see, I have created electricity with the chemicals. Okay, so he creates the first battery, and he does that in 1800. Okay, so this is a chemical reaction creating electricity, just like your lemon battery here. So just quickly explain what that happens. So look, his voltaic cell has copper, look, zinc, copper, zinc, copper, zinc, copper, zinc, copper, zinc, copper, zinc, in between a little electrolyte, okay, and that creates an electric current. So in your lemon cells, we have magnesium and we have copper, and they're reacting. The magnesium is reacting with the acids, okay, in your lemon, and it's going into solution. So it's becoming magnesium ions are going into solution, and they're freeing up electrons. Electrons are going, hey, where should we go? Okay, but you've got a circuit. You've got a circuit. And meanwhile, there's hydrogen ions swimming around in the lemon, and the hydrogen ions are going, I just want some charge so I can break free and become a gas. And what do you see? If you look at your magnesium, can you see the bubbles of hydrogen gas that are appearing there? Bubbles of highly flammable and not very useful in this context, hydrogen gas. So those bubbles of gas are appearing because the hydrogen ions have collected their electrons, and the magnesium's gone in solution, and it's a circuit, so the electrons are flowing, look, all the way around the circuit and lighting our LED. Is that okay? Everybody okay with that? Ta-da! So that's what's happening in your little battery right now. The copper, like that's why copper's used for drinking vessels and for pipes and stuff like that. The copper's going, whatever, just give me the electrons, I'm okay with those. I'll pass them on to me mate, the hydrogen ions. So the copper's not really playing much of a part in here just yet, okay? Is that okay? So what we need to do now, of course, from about 1800, is the people go, oh my gosh, can I get a bigger battery? Can we get more juice? Can we get bigger and bigger currents going? Some of that. They didn't really quite know what the language was just yet. And of course, you've got people like in the Royal Society called Humphrey Davy, who went, oh my gosh, thank you, Galvani, got this little tiny cell. I want a much bigger one. So he creates a massive battery. Chantal, yippee! Don't forget, you might need the darkened lights to see the LED. Okay, so I'm going to stop on the history tour there for a second, and then we'll come back to the experiment, if you don't mind. And we'll just check. I'll just quickly check. Should we start the second experiment? Start the Danielle cell? Cool, got some thumbs up. So we're swiftly on. Lovely, lovely, lovely. Kiana, Adrian, Chantal, Philip, lovely, smashing, and Ram. Excellent. Okay. So I'll just switch my view, hopefully to this one. Where are you? There we go. So if we disconnect your lemon battery, you can come back to that one if you wish. So disconnect that one and put your little LED to one side, the red one to one side. And then we need all these leads, you see. Okay. And if you take out the little bit of magnesium and give that a little bit of a wipe, you can see, look, where the magnesium has reacted with the acids in the lemon. Effectively, you've created things like magnesium ascorbate and magnesium citrate as well. So we just give those little pieces of metal a little bit of a wipe and clean them off a little bit. And put those again to sort of one side, and we put our lemons to one side. So the next things that we need for this, so what we're going to do now is going to do the the Daniel galvanic cell, and I'll explain all the science behind this in a second. Just going to mop up a little bit of my spilt lemon juice. So first things first, if we pop our little stand, our little sample tube stand there, we then first things first, if we pop the copper sulfate, so we need to pop the security things on copper sulfate. And of course, if you haven't got your gloves on at this point, can you please put your gloves on? And if you haven't got your glasses on, please put your safety specs on at this point. Okay, so please put safety specs on at this point and your gloves. Okay, thanks, Ram. Thank you, Ram. Okay, remember, now you guys are old hands at this, so you know that sometimes you've got to give these little security plugs a bit of a wiggle. So pop your little safety pin in there and give that a little bit of a wiggle. And there we go. Okay, so that's one, and I'm going to give that one a little bit of a wipe here. Okay, the next thing we need is the zinc sulfate. So if you grab the zinc, is that the periodic table Kayana? Yes, it is the periodic table behind me. One of the greatest feats of discovery, scientific discovery of all time. An amazing work of science and beauty. Remember, if it ain't on that table, it doesn't exist. Okay. Right, so give the little tiny plug a push. This one's a little bit stiffer than normal. There we go, perfect. Now, the other metal in the fray that we need here today is the zinc. Okay, so we're going to be using zinc here. So again, I'm just going to cut the top off that one. Okay. And take out one of the little zinc rods. So do have a look at these metals when you take them out and compare them in terms of their hardness, their shininess, their colour, their bendability, because this is elemental zinc. So behind me on the periodic table you can see elemental zinc, elemental copper and magnesium. Okay, so just take one of those little rods of zinc out, so it's just rolled to one side unhelpfully. Okay. And then just take one of your little copper rods that you've had that you cleaned up. I say take one of those little copper rods. And then what we want also is one piece of the felt. So one little piece of the felt. So what we're creating here is a similar type of cell to the lemon cell, but I will explain this. What is zinc? Philippe, Zn is zinc. That's the element zinc. Okay, and it's, oh, Adrian, well done, nice one, Adrian. Spot on. Right, so the next one, you take your little lid, okay, and place one of the little sample pots into your holder, and then place another little sample pot into the holder like so. And what we want to do is you can see on your sample pots, you see the 5 ml line, there's a little 5 ml line and a 5 ml line on that one. You're going to place 5 mils of copper sulfate into one. Okay, and then 5 mils of the zinc sulfate into the other. Okay, so that's 5 mils of copper sulfate into one and 5 mils of the zinc sulfate into the other. So remember that, and just pay attention to that. There's two sulfates. So there's a copper sulfate and a zinc sulfate. Okay, so copper sulfate and zinc sulfate. Everybody okay with that? Right, now the next thing to do is get your little bit of felt and pop the little bit of felt into one arm. So bend it in half effectively, and then put the other bit of felt into the zinc sulfate. So one into the copper, and you'll see automatically by sort of capillary action that there's solution moving along the felt there. But just to help that connect, okay, and it's really important that we connect that, is put about 3 or 4 drops of the copper sulfate. This is important for later. So put about 3 or 4 drops of the copper sulfate on that felt to help them make sure that it's nice and soaky and nice and damp. Okay? Hopefully everybody's okay with that. Philippe, 5. Yes, about 5 drops. Philippe, thank you. Yes. Okay. Everybody okay with that? Yep. Cool. Right. Now, with your black lead, can you find and connect it to the zinc rod? So feed, you might want to pull a little tiny protective guard off your crocodile clip. So put the black lead onto your zinc rod, okay, and put that into the zinc sulfate. Okay, so pop that into the zinc sulfate tube. Now get a copper rod, and you might again pull the little tiny protective sleeve back on your crocodile clip like that to make it easier to access, and pop a little tiny copper rod into that little crocodile clip. Okay, and pop that into the copper sulfate. So pop that into there like so. So I've got one zinc rod in the zinc sulfate and one copper rod in the copper sulfate. Now, you then need to find your green LED. So this is the little green LED, all right? Now we know that these LEDs work because, of course, they work because electricity is flowing through them. Current or electrons are flowing through the LED. So again, remember which side is positive. So the long leg is positive, so the long leg is positive, and that goes on the red lead, or the red terminal, and the black lead is negative, and that goes on the crooked leg. And now that's a little bit frustrating, and I'm just going to switch to face cam. Don't, at this stage, be put off. Don't be dismayed. Don't go, oh my gosh, my experiment is not working. What has gone wrong? The point is here that that little LED, like a light bulb of any kind, needs a certain amount of energy to work. And maybe here, we just haven't got enough juice for that LED to work. So what we've got to do is we've got to amp up the amount of volts going through it. We've got to amp up of electrical energy going through our circuit. So let's double up our, so what we've effectively got here is a single cell. We haven't got a battery. What we need to do is create a battery. So how do we do that? So what we do, just dismantle that for the time being. So just disconnect your LED for the time being. Just pop that to one side, okay? I'm just going to pause there briefly, just going to pause and just ask a question. Is everybody okay? Could I have some thumbs or some questions? You can ask me questions if you want at the moment. If kind of some thumbs. Ram's okay, Adrian's okay, Kaina's okay, Chantal's okay, Asia's okay. Awesome, awesome, and Caroline's okay. Good, brilliant. You guys are excellent scientists. I knew you were the moment you signed up. Excellent. And Ram, I got a party going on. Okay, so put your two more containers like that, your two little sample pots next door to that. Now what we're going to do is we're going to double up what we did with the last one. So again, with this one, we have copper and zinc. So copper and zinc. We now need copper in this one. So if you fill up the copper again to the 5 mil mark, so we might need, I think we do need a little bit more copper. So I'm just going to take a little bit more copper sulfate from the other copper pot you've got, so your spare copper one. Of course, you've got spare copper in there to do this several times, okay? Okay, so just top that up with a little bit more copper. That's it. Put the lid back on that. And then, of course, we need the zinc sulfate in the next one. So squirt all that to the 5 mil line. And again, we're just a little short on the zinc sulfate for that. So I'm going to take a little bit more zinc sulfate just to top that up to 5 mils, okay? Okay, so there we are. Just top that up to the 5 mil mark with the zinc sulfate. Now, once again, ladies and gents, we need a zinc rod in the zinc, and we need a copper rod in the copper sulfate. So you need to grab yourself another zinc rod. Okay, get yourself another zinc rod and connect that to, again, put the black lead on the zinc. So put the black lead, you might need to just again remove that guard. Put the zinc rod into the black lead. Okay, then put a little bit of felt connect a little bit of felt between that zinc sulfate and the copper sulfate. So connect those up. Make sure the felt is in the liquid. Okay. Then get your copper rod. So get your copper rod in your red lead. So copper rod in the red lead, like so. So copper rod in the red lead, and pop that one into the copper sulfate. Okay. Okay. Is everybody okay so far? Everybody okay so far? Yeah? Yep, cool. I've got a couple. Yep, lovely. Couldn't the LED have burnt out? Ram, you're absolutely right. Without doubt, these are quality attested before they come off the manufacturing line. They can't leave that generally. But just occasionally, and these haven't been used before, so they're brand new. But just occasionally, you do get them that malfunction. They are pretty inexpensive, specialist bits of kit. But you can guarantee 9.9 times out of 10 it'll be okay. Okay, but that's a good point, Ram. I like your point. Right. So now what we need to do is, you see you've got a black and a red in the middle. Okay, you've got a black and a red in the middle. You just need to connect the two crocodile clips here, making sure the rods stay in the solutions. So connect the red and the black clip together. Okay. Now you should have then, just a sort of sense check, copper, zinc, copper, zinc, copper sulfate, copper sulfate, zinc sulfate. So I now have a positive end and a negative end, okay? Positive end and a negative end. So black is negative and the red is positive. So again, if we then try to connect, remember, the positive end, which is the red lead, making sure the rods are still in the solution, and then the black end, oh, my rod has disappeared out of solution, damn. Okay, then the negative end there with the negative end of the lead, and then, way, saw a little glow there. Fantastic, I've got a little green glow. Got a little green glow, amazing. Okay, I'm going to switch the lights off to show you the green glow, okay, because it's very bright in here in the studio. Oh. And just switch that one off for a second. It's very faint, but it is definitely a green glow. Hang on, let's just go. No, my rod's out of solution again. Get back into solution, you. So you can, I think, hopefully everybody can see a little green glow there. Everybody can see a little green glow. Excellent, like a little glowworm. I've got a little glowworm in me lab. I cheated. It's a glowworm. The red one is connected to the copper sulfate. That is correct, Adrian. Yes, AZ, well done. Now we can actually make this glow a little bit brighter. Now, a little bit brighter. I'll just switch on one light, so I'll just explain what I'm doing. We can make this glow a little bit brighter if you identify your sodium hydrogen sulfate bottle quickly. So identify your sodium hydrogen sulfate bottle quickly. Okay, so pop the security top off that one. Security top off this one. Pop that in like so. Come on, it's a bit troublesome, this one. Go on. There we go. Now what you're going to do with this, you're going to put two or three little drops, okay, on the salt bridge, both of these salt bridges. Okay, pop them 2 or 3 salt bridges, drops on the salt bridge. Maybe it might take maybe 4 or 5 drops. We'll put maybe 3 or 4 or 5 drops on it. Now I'm going to try and do this in the dark and show you the effect on my little green glowing diode, okay? Whoops, pop that one off. So here's my little green glowing diode, and I'm going to pop a couple of little drops. And you should see the little diode glows brighter. Dee-dee, little bit brighter. Look at that. Look at it glowing. I mean, all I need is 3 or 4 of those. I can light up the kitchen. Hey, ah! Cool. Okay. So, Is that okay? Has that worked for everybody? Well, I think we're I think probably trying to get... Thank you, AZ. Thank you. Yes. Yay. AZ says yes. Adrian says yes. Got a couple of yeses. Aha. Chantel says yes. And nobody else says yeses. Not yeses. Just a couple of yeses. Chantel's got a heart. Oh my gosh. What is LED? RAM. LED stands for light emitting diode. A light emitting diode. Caroline. Thank you. Excellent. Caroline says yes. Oh, fantastic. So a diode is a device. A diode is a device that allows electricity to flow in one direction and not the other. And there's all sorts of kinds of diodes. This particular type is a light-emitting one, so it just gives out a little bit of light. Okay. If you don't mind, I'm going to just quickly pop to the slideshow again, so I can explain a little bit of the science. So this is the Daniell cell, named after John Frederick Daniell, who was a British chemist and physicist in the 19th century. And what he was trying to do was trying to work out how can we make a battery that doesn't produce all this hydrogen, because it's flammable and it stops the cell working, or stops the battery working. So he came up with the original Daniell cell. So you can see here there's some copper pots with some clay structures in the center, porous sort of clay structures in the center, and then a different electrode in the center of each of these pots. These pots, this battery, is a battery effectively, doesn't produce hydrogen. Okay, so how does that actually work? What's happening in your little tiny, your trainers? So what's actually happening when you connect it up, everything, is the zinc. Can you see the zinc here, the metal zinc? It goes into solution, and as it goes into solution, okay, as it goes into solution, it loses an electron, or it loses a couple of electrons, and they go scootling up the big... And the copper ions that are swimming around go, oh, I wish I could be a copper metal again. It goes, oh, electrons, thank you so much. And it becomes a metal. So the copper comes out of solution and the copper goes into solution. Okay? So effectively, this is what's actually happening. So one side of the cell actually becomes more negative and one side becomes more positive. So that's electric current flowing through the wire. But why do we need the salt bridge? So the salt bridge is required, that little bit of felt that you've got there, that's required to keep the balance in the cell. So it doesn't stop it becoming too negative and stop it becoming too positive, okay? So the salt bridge allows different ions, positives to go to negative, negative to go to the positive, and therefore the cells can become balanced. But remember, the first electrolyte that we used to do that was copper sulfate. The one that made the little LED go bing was sodium hydrogen sulfate, and that allowed more electrons to flow effectively far better, okay, because that's what makes it brighter. You've got more energy, okay, more electrons are flowing. Is that okay? Cool. And that's basically a summary of what's actually happening, is that zinc is going into solution and becoming zinc ions and freeing up electrons. The copper is coming out of solution, taking the electrons and becoming copper metal. So that's what's actually happening. So in time, effectively, in time, the zinc would actually degrade and the copper would become bigger and fatter, as it were. Is that okay? Right. Are there any questions? I hope that's all made kind of sense. Any questions? You can ask me questions, you can unmute you, or you can type the things in, or I'll be forced to tell you a joke. Philippe, I shall ask to unmute you. Yes, Ash, if you could unmute Philippe.
The parts, if you, these parts, if you wash them, can you use them again?
Yes, you can. Yes, of course you can, yeah. So just wash them in a little bit warm water, Philippe. Perfect little question. Lovely. You're welcome. Any other questions? It's all gone very quiet. You're all very studious. You're wandering around glowing little LEDs everywhere. If only it was bigger. In which case, I will be forced to tell you a joke. If a king sleeps in a king-size bed and a queen sleeps in a queen-size bed, where does the prince sleep? Where does the prince sleep? Yes, Philippe. Asked to unmute.
In a twin-size bed?
Nice guess. Nice guess, Philippe, but no. An air mattress. Get it? An air mattress. Ba-bum! H-E-I-R, of course. An air mattress. I've got a question. AZ, what would happen if the salt bridge wasn't there? AZ, the quickest way of checking that baby out is to flip the salt bridge out, and you'll soon see that you broke the circuit. So you need the salt bridge to basically connect the circuit. It basically makes the circuit complete. Okay. Any other questions? Any other questions? Guys, feed me questions. I hope you've had fun. I hope that's been useful. I hope that's been interesting. Of course, this is just the start of your journey into science of batteries. And of course, you've got lithium-ion batteries and stuff like that that we use today in our mobile phones, in super cool cars like the Tesla car and stuff like that. Adrian, is the recording for this meeting? Yes, the recording will be published tomorrow at some point. And of course, battery technology. We've probably got the ion battery technology for about the next 10 years. I would have thought it's getting better and better and better. But we're going to need some new and totally mind-bending, revolutionary... Is this our first class? This is our first class. Do you teach all of them? Chantal, I don't teach all of them. I teach some of the chemistry and some of the physics. Caroline, Asia, you're very welcome. You're absolutely welcome. Delighted. Thank you so much for subscribing to MEL, and do come back. I'm going on a delayed honeymoon next week. So I won't be around for a week or so, but my good friend Sparky Mark will be here for next week and the week after, and then I'm back towards the end of September, the last week in September. So I'll be back in the end of September, if that's okay. Got a hand up. Kayana. Yes, Kayana. Question. Give me questions.
Were you in the kitchen?
Sorry?
Were you in the kitchen?
Was I in a kitchen?
Are you in the kitchen?
No, I'm not in a kitchen. No, this is a lab. It's just got a little bit of an artificial background and stuff like that, but I'm actually in a lab.
We should do kissing. Okay.
Is that all right? Okay, I'll ask to unmute. I've got to ask you to unmute you again, sorry. Ash, if you could unmute Kayana again, and Lucas. Go, Kayana, Lucas.
I don't want anything. You were... I said in the kitchen. I asked... You wanted that one. I didn't want that. Whatever.
Is it, yeah. Kayana, what was the question? Did I mishear it?
No.
Or did you say, am I a teacher?
No. He thought I had the question.
Okay. Yeah, no problems at all. If you've got a question and you want to do it later, then you can just simply type into support at melscience.com and you can send any questions to us. We're very happy to answer any questions. Aji, thank you very much. Thank you very much for that. Where to? Greece. Go to Greece. I had an awesome time. Adrian, you're very welcome. Absolute pleasure. So, once again, ladies and gents, thank you so much for timing up. I hope you had fun. I look forward to seeing you next time. And on that note, until that time, I wish you a very safe and wonderful weekend ahead. Of course, it's just around there. And if you're in America, of course, you've got Labor Day in a minute. Chantal, you're very welcome. Pleasure. And I really hope you have a once use the lemon to make the button controllers. Yes, you can. So on the note, goodbye.